Hello, welcome back to another of Rotten Reads. This Rotten Read comes to us from the University of Toronto. So thank you, U of T. This is some of their news. It's called the Antarctic Project IceCube, named Breakthrough of the Year by Physics World. And this is older article. So it is from December 13th of 2013, 1313. And in case you don't know, just finding interesting things and sharing them. The IceCube Lab in March 2013. There it is. The IceCube Laboratory is the Amundsen Scott South Pole Station in Antarctica, hosts the computers collecting raw data due to satellite bandwidth allocations. The first level of reconstruction and event filtering happens. So what does it say? International High Energy Physics Research Project IceCube has been named the 2013 Breakthrough of the Year by British magazine Physics World. Antarctica Observatory has been selected for making the first observation of cosmic neutrinos, but also for overcoming the many challenges of creating and operating a colossal detector deep under the ice at the South Pole. And it has a quote here: "The ability to detect cosmic neutrinos is a remarkable achievement that gives astronomers a completely new way of studying the cosmos." This is by Hamish Johnston, editor of physicsworld.com. He says the judges of the 2013 award were also impressed with the IceCube collaboration's ability to build and operate a huge and extremely sensitive detector in the most remote and inhospitable place on Earth. Essentially, a telescope in the ground, the IceCube Neutrino Observatory was completed in December of 2010 after 7 years of construction at the South Pole, but the idea of a huge detector buried in the ice was conceived a long time ago. And in the 1990s, the Amanda detector was built as a proof of concept for IceCube. By January 2005, the first sensors of IceCube had already reached 2,450 meters below the Antarctic ice sheet, and a few weeks ago, the IceCube collaboration published the first evidence for a very high-energy astrophysical neutrino flux in Science. "This is the beginning of a new era for astronomy," says University of Toronto physicist and IceCube collaborator Ken Clark. This result opens up the ability to use neutrinos to explore our universe. These really are the ideal messenger particles, since they can travel vast distances without stopping or slowing. IceCube principal investigator is Francis Housen, the Hilldale and Gregory Bright Professor of Physics at the University of Wisconsin-Madison. As he envisioned, the Antarctic ice became the perfect medium to search for high-energy neutrinos that, after traveling through the universe during millions, even billions of years, haphazardly interact with the nucleus of a molecule of ice. "I did not imagine that the science would be as exciting as building this detector," says Housen. "Challenges were many, from deciphering the optical properties of ice that have never been seen to drilling a hole to 2.5 kilometers in 2 days and then repeating it 86 times. The success of IceCube builds on the efforts of hundreds of collaborators around the world, from the design, the deployment in harsh environment, and the Amanda prototype to data harvesting and physics analysis. IceCube is composed of 5,160 digital optical modulars suspended along 86 cables embedded in a cubic kilometer of ice beneath the South Pole. It detects neutrinos through the tiny flashes of blue light called the Cherenkov light. Maybe I'm saying that wrong. They are produced when neutrinos interact in the ice. The photo below shows an IceCube string being lowered below the ice. Thanks to the IceCube NSF is who provided this photo. The deployment of each of the 86 IceCube strings lasted about 11 hours. In each one, 60 sensors called DOMs had to be quickly installed before the ice completely froze around them, and we can't see the picture. Physics World will be hosting some other things. A Google Hangout on Friday, December 13th at 11 a.m. Eastern Standard Time with Hamash Johnston, the editor of Physics World. He'll be in London. Francis Halving, the University of Wisconsin-Madison professor and principal investigator of IceCube. He will be in Madison, Wisconsin. And James Roth, a member of the IceCube collaboration and senior electronics instrument specialist at the University of Delaware. He'll be at the Amundsen Scott South Pole Station. The hangout can be viewed here. The IceCube Neutrino Observatory was built under a National Science Foundation Major Research Equipment and Facilities Construction Grant. With assistance from partner funding agencies around the world, the project continues with support from Maintenance and Operations Grant from the NSF's Division of Polar Programs and Physics Division, along with international support from participating institutions and their funding agencies. UW-Madison is the lead institution, and international collaboration includes 275 physicists and engineers from the US, Germany, Sweden, Belgium, Switzerland, Japan, Canada, New Zealand, Australia, UK, Korea, and Denmark. And there is a video you can watch. So that is that little bit of information about the IceCube project breakthrough of the year for 2013. Have you heard of this? What do you know of this? What do you think they're going to use this information for? You know, leave your comments